when t from -2 to 0, the function is 0. So ft equal to 0 when t from -2 to 0, and ft equals to t when t from 0 to 2. Okay, so when we recall the what is predict function, what predict is a function that is plotted from -l to l, alright, which has a fundamental period t equals to 2l. So based on this given function, negative l to l, one complete cycle is from -2 to 2, -2 to 2, therefore l is equals to 2 and t equals to 4. So it's given here. Alright, so what does it mean? It means that every time t increases or decreases by 4 units, the function will repeat itself. Okay, first question is sketch the function over the interval -6 to 6. Determine whether the function is even, odd, or neither. This is the first step of Fourier series. You have to sketch and determine the type of the function. Okay, the second one is find the Fourier series of the function. Okay, look at the sketch of the function. It's given here. Okay, so let's try to do it ourselves. Now I change the color to green. Right, t from -2 to 0, the function is 0. So from -2 to 0, the function is 0. Right? Okay, and t from 0 to 2, the function is t. So this is how you sketch the function. Ft is a piecewise function that has two different functions in two different interval. Okay, now we have to extend the function over the interval -6 to 6, because this is the it's just as easy as t increases 4 unit from 2 to 6, then you just need to draw the same plot as the first plot here. Alright, again from -6 to -2, the same plot. Okay, so you can see that the function, when we plot it, it has this continuity point at every time period t equals to 4, right? Okay, now let's make decision what is the type of the function. It's clearly seen that it's a neither function, since it's not symmetric by the y-axis and also not symmetric by the origin. Therefore, the function is neither even nor odd function. Okay, so let's solve the Fourier series using the original formula. So given that the formula is ft equals to a0 on 2 plus the summation on an cos n pi t over 2 plus bn sin n pi t over 2, n from 1 to infinity. Bear in mind that the 2 here, okay, the 2 here originally is L. Okay, since we know what is L already, then I already put the value of L into the formula. Okay, okay, so let's start with a0. So the formula of a0 is a0 equals to, okay, let's change the color of the pen to black. So a0 equals to, formula is 1 on L, integration from -L to L, ft dt. Okay, so this is equals to 1 over 2. Alright, so since it is a two different function in two different intervals, therefore we have to split the integration into two integrations. The first integration is from -2 to 0, where the function is 0. Okay, while the second integration is from 0 to 2, where the function is t. Okay, the first integration is all equals to 0. So we just need to solve the second integration. So 1 on 2, you integrate t is t squared on 2, limits from 0 to 2. So this is equals to 1 on 2, okay, 4 over 2, okay, equals to 1. Alright, so we know that a0 equals to 1. Okay, so let's move to an. So the of an, okay, the formula of an is equals to 1 on L, -L to L ft cos n pi t over L. Okay, so this is equals to 1 over 2. Again, we have to split into two integration. The first integration is 0. Okay, 0 times any function or any number is always 0. And the second integral is from 0 to 2, where the function ft is t and L is 2. Okay. Alright, so the first integration is 0. Okay, while the second integration is, we need to solve it using tabular method. Okay, so let's do the tabular method here. Okay, do you have t 1 0? We have here cos n pi t over 2. The first integration, we're gonna get cos n pi sine n pi t over 2, while the second integration is for negative 4 n pi squared cos n pi t over 2. Okay, cross multiplication. Okay, don't forget the sign. Okay, so this is equal to 1 over 2 2t over n pi. How do I get this? From the tabular method. Sine n pi t over 2. Okay, plus 4 over n pi squared cos n pi t over 2 0 to 2. Okay, then I can just simply cancel out this. This becomes 1 and this becomes 2. So means that you don't have to multiply it, okay, by 1 over 2 when we go to the next step. Okay, then we're going to substitute t equals to 2. The first term becomes 2 over n pi sine n pi plus alright, okay, 2 over n pi squared cos n pi. Okay, minus, then we're going to substitute when t equal to 0, first term. Okay, now when we substitute t equals to 0 into here, then this term is 0, right? Because t is equal to 0, and this term becomes cos 0. Cos 0 is equal to 1. Therefore, this is equals to 2 over n pi squared. Okay, remember in the previous video, I've shown you that we're going to use some tips or some useful identity trigger to reduce the difficulty, to reduce, or sorry, it's not to reduce difficulty, to simplify the answer. Okay, sine n pi is always 0. Cos n pi is minus 1 to the power of n. Okay, then our answer for an is 2 on n pi squared negative 1 to the power of n minus 1. Alright, so let's move to Bn. So Bn is equals to, the formula is 1 over L, negative L to L, ft sine n pi t over 2. Alright, then we substitute the L. Okay, again, we split the integration into 2. The first integration is 0, okay, from negative 2 to 0, and the second integration from 0 to 2, the function is t. Okay, again, the first integration is 0. The second integration, we have to use tabular method. So this is equals to 0. Okay, and this is tabular method. Okay, let's do the tabular method here. We have t 1 0. Okay, this is sine n pi t over 2. Okay, first integration, we're going to get negative over negative 2 over n pi cos n pi t over 2. Okay, and the second integration, you're going to get negative 4 over n pi squared sine n pi t over 2. Alright, then I'm going to put into here 1 over 2, okay, negative 2 over n pi cos n pi t over 2, okay, plus 4 over n pi squared sine n pi t over 2. Limits from 0 to 2. Okay, we're going to substitute the limits. This is negative 2 on n pi. Okay, we have t here. Okay, therefore in the upper part it's 4. Okay, cos n pi plus 4 over n pi squared sine n pi. Okay, minus 0 minus 0. Okay, since sine 0 is 0. Alright, okay. Useful identity trigo says that sine n pi is 0, while cos n pi is minus 1 to the power of n. Okay, we are about to finish the calculation. So this is minus 2 over n pi, negative 1 to the power of n. So this is equals to 2 over n pi, negative 1 to the power of n plus 1. Okay, then we're going to substitute the a naught. We're going to substitute the a naught, the answer for a naught, an and bn into the formula of ft. Okay, so what it's going to look like. So we have the answer is a naught over 2, 1 over 2 plus the summation of, so this is an and cos n pi t over 2 plus bn sin n pi t over 2. Okay, now let's imagine how the Fourier series look like graphically. So this is an, this is bn, and this is a naught. Okay, so how the Fourier series look like graphically? So can you imagine that when we plot the function ft, it has discontinuities, right? Okay, so how can this Fourier series make it a function that is a very beautiful continuous function? Alright, so we have the answer in the previous slide. Okay, so this is the integration from n equals to 1 to infinity. So let's sketch the function from n equals to 1 to n equals to 5. Okay, of the Fourier series. Okay, the blue color, the blue line is the function that we plot in the beginning. Okay, while the red line here is the approximation of Fourier series, sinusoidal Fourier series. Okay, when we take n equals to 5. Alright, it almost, yeah, it follows the shape of the function ft. However, it's not so accurate. So let's increase the n equals to 10. Now n equals to 10, we plot the function. You can just plot the function using any mathematical software, and the simplest one is Microsoft Excel. Okay, so it improve the prediction of the predict function. Okay, let's move to the next slide. Okay, it increase again. We increase n now is 25. Okay, yeah, it looks better than n equals to 10. If we double the n, when you plot n equals to 1 to 50, so you can see that the plot of the Fourier series looks similar to the periodic function. This is